Hello, everybody, and welcome to the ISTAT Learning Lab. Today, we're going to speak about supersonic air travel. We had a session on the 19th of October about exosonic, and it was quite technical. It was about the sonic boom and the noise on takeoff and landing. Today, we're having Boom Supersonic in the studio with its founder, Blake Scholl, and it's going to be more about the market for supersonic air travel. To introduce Blake, we have Adam Pilarski in the studio in Washington. And Adam is too famous to introduce, but I want to mention, though, that he was the 2020 ISTAT award winner. And he was the chief economist for McDonnell Douglas for many years. And then he became the chief economist for Avitas, and he's kind of the chief economist for ISTAT, as anyone who has ever attended an ISTAT conference can attest to. I also recommend that to understand Adam more in detail, you should read the current issue of the Jet Trader, where Adam has written a very interesting article. And that magazine is available on istat.org. During Blake's presentation, you can write in questions by clicking the Q&A button at the bottom of your screen. Use that one, not the chat button. And then after the presentation, I will go over those questions together with Blake and Adam. So I'm looking forward to a very interesting session. Before I hand over to Adam, I want to mention that next Learning Lab is on November 23rd, 10 o'clock New York time, 1500 hours Dublin time. And that's going to be with Leah Ryan from Alton, who's going to talk about aircraft-backed debt restructuring. And with that, I want to hand over to Adam Pilarski.
Thank you, Niels. Thank you, everybody, for joining. And thank you, Blake, for participating and enlightening us. It's a really great topic, and I'm very enthusiastic about it. 3 weeks ago, as Niels mentioned, we had a technical presentation of why the sonic boom is no longer as big a problem as people believed it was 70 years ago. No kidding, progress was made and things are different. We are going through hard times right now, and we in aviation, and usually after hard times, there are breakthroughs, technological breakthroughs that I am certain will happen and are beginning to happen. We'll have new types of airplanes. And I think that since the first flight, well over a century ago, we, the industry, made tremendous advances in every field except speed. We stopped at, with the 707 and jets, and from then on, it stopped. It's time to break it. It's time for me not to have to sit 16 hours on a plane going to China. So I'm very enthusiastic that we have some people who are developing new planes, supersonic planes. Now, some of us may remember the Concorde, and it was a government project. It was run by governments. It didn't address the needs of the market. I'm an analyst. Many other analysts would say, what's wrong with supersonic flight? It's too expensive. I don't think so. I think that people are willing to spend the money, but I'm very glad that we will have the speaker today is a very enthusiastic and knowledgeable and insightful person, Blake. And from a personal point of view, I do this test. Is this plane real? And it is real if there's a model. So here's a model, and this is years ago. It was signed by Blake. And recently, a few months ago, I visited in Denver his facility where they are actually producing the first Boom plane. And here's a model in United livery. They sold it to United, and this time it's signed by both Blake and the leadership of United, Scott Kirby, and our own Jerry Lederman. So I think that this is for certain something that will happen, and I can't wait to fly supersonic. And I want to hear, Blake, you explain to everybody how it will happen and what are some of the obstacles. And then maybe we can discuss it a little in depth. And then we'll go back to Niels, who will relay all the questions that ISTAT membership has. So I am done. How do we get Blake on now?
Morning, Adam.
I'll mute myself.
Good morning, Adam, and good morning, everybody. Thank you so much for tuning in and for having me here. I am very excited to share the story of Boom and how we are now really on the cusp of a renaissance in supersonic flight. And unlike Concorde, which was really kind of the epitome of unsustainable transportation, both environmentally and economically, supersonic flight's coming back in the very near future. And this time it's here to stay, and it's going to change how tens of millions of people get around the planet and eventually everybody. To give you a little bit of history of Boom, the company recently turned 7. And 7 years ago, Boom was me, a PowerPoint, a spreadsheet, and a big idea. And fast forward to today, as Adam said, we've now built and rolled out history's first independently developed supersonic jet. And we've had a landmark order from United, the first firm order for a supersonic airliner since the 1970s. And while Boom has made huge progress in the last 7 years, one thing that hasn't changed is why we're doing this. And this is fundamentally a mission-first, technology-second company. With the way we view our purpose here is to make the world dramatically more accessible. And in a way, this is the mission statement for aviation in general. We've made the world a much smaller place. We've opened up new possibilities for humanity. And overall, that happens by building flight that is faster, more affordable, more convenient, and importantly, dramatically more sustainable than what we have today. And so if we make progress on those 4 things, speed, cost, convenience, and sustainability, we can build a world in which more people go more places more often. And that's a better world for us to live in and a better world for our children to grow up in. Now, Boom, until very recently, the only place on the planet you could see a supersonic civil aircraft was a museum. And happily now that has changed. So what you're looking at here is the XB-1. This is the prototype, the supersonic demonstrator for our Overture airliner. It's about a 1/3 scale airplane. If you know the history of Concorde, it is very analogous to the Ferry Delta II. That was the similarly about 1/3 scale prototype that paved the way for Concorde. And so this is history's first independently developed supersonic jet. Previously, it's been governments and militaries only. This is privately funded, independently developed, and literally about 2 weeks away from running its engines on the ground for the first time. It'll be in the air first half of next year, starting to set speed records. But if we turn back the clock a little bit and look at the history of speed, since really the dawn of the Industrial Revolution, as a species, we have made regular progress at speeding up transportation. And every time we speed up transit, as a species, instead of spending less time traveling, we actually spend more time traveling because the possibilities are so much greater. And to really understand that, it has been so long, as Adam indicated, since we've had a speed up. It helps to very carefully study what happened last time when we had a speed up, when we went from propeller aircraft into the jet age. And everywhere you look, the first order and second order consequences were tremendous. For example, Hawaii was basically not a tourist destination before jets. It simply took too long to get there. When it was 16 hours from San Francisco to Honolulu, you'd vacation in wine country instead. Yet with the speed of the jet, travel to Hawaii went up sixfold in the first 10 years of the jet age and kept on growing for decades as second order effects kicked in. We started to have hotels, and resorts, and tourist attractions. The Beatles took the first world tour in the 1960s, really thanks to the speed of the jet. It would not have been possible 10 years earlier with the slower aircraft that had come before. And perhaps most significantly, we have not had a world war since the dawn of the jet age. And now I don't think flight's the whole story there, but I don't think it's irrelevant either, because in-person interaction is so humanizing that it allows us to resolve what otherwise would have been very significant conflicts. Now, as we look forward to what we're doing here with Overture 1, again, this is every bit as significant as the speed up from propeller aircraft to jets, with a true doubling of flight speeds. And what that means in practice is that saving of hours in the air multiplies into savings of days on the ground and enables you to take trips that otherwise you just wouldn't take. So instead of flying from the East Coast to Europe as a red eye, you could leave in the morning, be there in the late afternoon, go out to dinner, and if you want, even be back that same day in time to tuck your kids into bed. And across the Pacific, time savings are even greater. What takes 3 days to do today could be done in just 24 hours. And those are sort of the first order effects of supersonic flight. But it's not about saving time on airplanes. It's actually about the trips you wouldn't take and the possibilities to get unlocked. Now, if you're saying, okay, Blake, if this is such a good idea, why is Concorde found in museums and not in our airports? And Adam really told the foundation of that story quite well. The first 50 years of aviation was commercially driven. The Wright brothers built their airplane because they thought there would be a market for it. Douglas built the DC-3 because he saw a large market of aircraft to sell to airlines that could be operated profitably at fares that passengers would pay. And similarly, the first generation of jet aircraft, the de Havilland Comet, the 707, were built with a commercial foundation. And yet in the 1960s, we shifted from a commercially driven model of innovation to a national prestige driven model of innovation. And so Concorde was a joint venture between the French and British governments. And much like Apollo, the goal was to just show up the Russians. So, fly fast, try not to crash, do it better than the Soviets can do it. And let's not think too hard about the economics. And so while it was a technical marvel, it was never designed to be environmentally or economically sustainable. Building out of 1960s technology, this is an airplane that was designed with slide rules and drafting paper and afterburning converted military engines, heavy and complex systems. So the result was that the airplane had exorbitant fuel consumption. It had significant noise and emissions issues. It didn't have the range to do very many routes, and it was only profitable at exorbitant fares, something like a 4 times first class fare. And when the fares are that high, not enough people can afford to fly, you can't get load factors, and the whole thing is more thud than boom. But fast forward to today, we are at a really exciting moment because we're at the intersection of market and technology to enable the first really mainstream supersonic flight. So starting with market, leaving the COVID disruption aside, we've now got 7 times more international passenger travel than we did when Concorde was conceived, and about 2.5 times since it retired in 2003. At the same time, the passenger demand for speed and flying experience have only increased, and I think the advent of video conferencing is going to make us less tolerant of slow flights. At the same time, airlines' need for differentiation has never been greater. So the market is looking for something new, different, better. There's more international travel than ever before. And at the same time, we've changed everything about how we design and build airplanes, except how fast they fly. So we've gone from aluminum to new materials like carbon fiber composites. We've gone from designing with drafting paper and slide rules and wind tunnels to being able to do digital engineering, where we can fly hundreds of potential airplane designs through virtual wind tunnels, enabling aircraft that are significantly more efficient. And last but not least, we've completely changed the architecture of jet engines, of course. Today, you can do supersonic flight without afterburners, without turbojets, with a clean, quiet, efficient turbofan engine. So that's what we're doing at Boom here. So improved materials, improved aerodynamics, significantly more efficient engines, bringing together really 50 years of fundamental innovation and basic technology into a breakthrough new design airplane that most importantly achieves an economic and business model breakthrough, allowing supersonic flight that is affordable for passengers, profitable for airlines all over the planet. And with that XB-1 aircraft having rolled out, we've now proven out not just that basic technology works, but the design is there, it's ready to go as well. So how are we going to do this? Ultimately, I believe in a future where anyone on the planet can benefit from high-speed flight, but we're not ready for that yet. So with Overture 1, we're focusing on today the most profitable passengers for international airlines. So that's the people who fly premium class, first in business today, the 19% of seats, but as we know here, it's more than half of the international airline revenue and substantially all of the profit. So focusing on the most significant passengers. And the basic concept here is these are passengers who hate the slow flights so much that they are willing to pay top dollar for a flying bed and try and sleep through the flight. And the basic concept of Overture for those passengers is you can trade in your flying bed for the best bed in the world, which is one at home the night before you have to leave. And then you can have a nice flying seat, arrive in half the time, and be home quicker as well. So when we talk to those passengers, these folks are hungry for faster flights. Over 80% would buy a seat tomorrow as soon as the airplane were ready. And when we ask them about pricing, they would be willing to pay an average of a 63% premium above today's business class fares. Now, that contrasts with Concorde that tried to create a market at 4 times. We don't think there's a very large market with that kind of a fare premium, but the market research suggests that even at very significant, 63% premiums versus today's subsonic premium class, there's a very large market, and the good news is Overture is profitable many times even with no premium versus the existing market fares. So when there is a speed dividend, speed premium at all, this can become the highest margin product for airlines to offer. So that sets Overture up really to be the first supersonic airliner that's ready for mainstream adoption. Uses modern technology, like I said, no afterburners. It is an aircraft that actually can fit in narrow body gates, making great use of the most available airport infrastructure. If you can park a 737 or 757, you can park an Overture. On board, passenger capacity is 65 to 85 seats, meaning if you're an international airline and you can fly fly a wide body aircraft on a route, fill the seats and get good load factors, you can do the same thing with Overture on the same route. Carbon fiber composite fuselage, Mach speeds twice as high as any other airliner flying to now. Plenty of range to do transatlantic and even North Pacific nonstop. When we talk about range, this is full payload with reserves. This is not a ferry range. So 4,250 nautical miles of real usable range, cruising up to 60,000 feet. And then I'll come back and talk about this more later, but very significantly running on up to 100% sustainable aviation fuel. So that the future can be not just faster, but also more sustainable. Unlike Concorde, this is an airplane that generates significant profits for international airlines. And why does that work? Well, we start with the highest yielding passengers already, the folks who are flying front cabin today. And we offer them a product that they are willing to pay more for, with an operating cost that's pretty similar to the operating cost per seat mile of a subsonic wide body in business class. So that means you get more profitability per seat, more profitability per flight. And because you can do more flights with the same airplane and crew, you can significantly improve asset profitability versus the legacy subsonic aircraft. So on New York to London, which of course is the biggest business travel route in the planet, you can make 4 times as much profit per year flying an Overture versus the most efficient subsonic airplane you can get from a Boeing or Airbus today. And in routes like LA to Sydney, which of course is just one of the most painfully long flights on the planet, you can flip what in 2019 was a loss-making route to actually a profitable route. And this works all over the planet. Now, Boom's approach here is with Overture 1, we are not counting on a restriction lift to supersonic flight over land. So we are focusing on routes that are primarily transoceanic, meaning you can get a 2 times speed up over water and about a 20% faster speed up over land. So you're flying right under the speed of sound over land, and you're opening up the throttles over water, getting a big speed up. And as you can see here, you can also optimize those flight routes to spend more time over water, less time over land, give passengers a big speed up. And over 500 of these transoceanic routes are ready to be profitable with Overture, meaning they have enough passengers for regular scheduled service, and at reasonable fare premiums versus today's subsonic flights, they're going to be profitable. Now, on board the aircraft, Concorde, for many reasons, was really just a bucket list item for passengers. This was at sky high fares. Think $20,000 a ticket round trip across the Atlantic. It's not something that many people could afford to fly regularly. And similarly, on board the aircraft, it was a premium ticket, but not really a premium experience. It was kind of like being in an economy class cabin today, but you got champagne and caviar. And on board Overture, we're not just reducing the fares, reducing the operating costs so airlines can reduce fares. We are building a passenger experience that's going to be one of the best things in the sky, something that passengers are going to fly over and over again. So throughout most of the cabin, it's a 2+1 seating arrangement. So you can sit by yourself, have window and aisle, or you can sit next to someone you're flying with. Large personal space at every seat. Seat with multiple different positions so you can get comfort, a large experience for work and entertainment at every seat. And my personal favorite feature is a cup holder that is nowhere close to where you'd have your laptop. That would have saved me for a few times. And last but not least, up at 60,000 feet, the sky is a deeper blue. You can actually see the curvature of the Earth. So there are going to be large personal windows at every seat. Now, if you design the airplane, our future is really defined here by 3 core design principles: speed, safety, and sustainability. So I'll speak briefly about each of those. With doubling of speed, it really transforms how we think about distance. Now, as many of you may know, Japan Airlines was the first airline to pre-order Overture, and working out that partnership, I went to Tokyo a lot. And today, if you're going to Asia, you have for say a Monday morning meeting, you have to leave midday Saturday. You get there end of day Sunday, Tokyo time. You go to a hotel. You try to sleep. The next morning, your alarm goes off. You wake up and you try not to sleep during your meeting, and then you head home. And the whole experience takes a minimum of 3 calendar days. And you better not make any important decisions the rest of the week because you're so messed up from the jet lag. And supersonic flight completely changes that. So instead of leaving Saturday, you can leave a whole day later. A Sunday morning departure from the Western US arrives in Asia Monday morning, local time. And you're awake, they're awake. To you, it's early afternoon. And so you can do a whole day of meetings, catch an overnight flight back, and you're back in the US 24 hours after you left. And so the point of this is reduction in jet lag, and significant speed up in what you can do in a day or a week, and changes what trips you would even take. So it's not about one less movie or a little bit less email on the airplane. Now, this is an airplane that can meet, or in some cases even exceed, the subsonic safety standards that we have today. We're already deep into the process with regulators here in the US as well as in Europe. We're certifying Overture to the same rigorous standards that apply to all other subsonic commercial aircraft. And in many cases, we're actually able to raise the bar on safety versus what is accepted today on subsonic aircraft. And a great example of that is we've designed Overture to keep the pressure cabin completely out of the rotor burst zone for the engines, meaning that if there's, for some reason, an in-flight engine failure, as we know happens from time to time, all the passengers are completely safe, and it's close to a non-event. And not only have we been building the safety technology and safety into the design for Overture, we made the decision several years ago to make our XB-1 prototype airplane a human-piloted aircraft, which allows you not just to build your safety technology, but I think more importantly, to build your safety culture. Building an airplane and a culture where you're building something that ultimately is going to be safe and reliable for the flying public. Last but not least is sustainability. And here we took some real inspiration from Tesla. If you can think about electric cars before Teslas, you didn't really want to have one because they didn't go very far, they didn't go very fast, and they were unsexy. And Tesla did the world really the great favor of building the first electric cars that you really wanted to drive. And so from a sustainability perspective, if we want to accelerate the transition to sustainable flight, we need the aircraft that passengers most want to be on from a speed and comfort and convenience perspective to also be the best one for the planet. And the same thing applies to airlines. You want the most profitable airliner also to be the one that's best for the planet. And so we challenged ourselves to find a way to enable supersonic flight with 100% carbon neutrality. And the way we achieve that is by making this the first commercial aircraft that's designed to run on 100% sustainable aviation fuel. And as many of you know, these are fuels that already exist. They're working in small scale today. There is tremendous progress getting made in improving the economics and scalability of SAF. There's some bills in front of Congress right now that create tax incentives around SAF investment. And this is something that we're actively working towards. We're teamed up with companies like Prometheus that are working on next generation SAF fuels that are significantly more economic and significantly more scalable than first generation biofuels. So the overall opportunity for this airplane is very significant. We can think back to Concorde as an aircraft that only 14 ever entered service, thanks to the lack of route capability, the lack of profitability at mass market fares. It was just not a scalable aircraft. But today, if you look at the volume of premium passengers that will exist by the end of the decade on routes where Overture can give a big speed up, this is a 1,600 aircraft plus total addressable market. So this is an airplane you can see at ultimately at any major international airport. And we are seeing that start to play out in the market. As I mentioned before, Japan Airlines became the first airline to pre-order 20 Overture aircraft at a total deal value of $4 billion. And earlier this year, United Airlines made history by placing an order for 15 Overture aircraft. That's $3 billion in Overture airplanes, plus taking pre-orders on another 35 airframes. So we're up to a $10 billion Overture fleet there for United. And this is significant in so many ways, including, think about that 15. That's more Overtures, on firm order with deposits from United than Concorde's ever entered service. And ultimately, we see this as a tool that every major international airline is going to need in order to stay competitive. When it takes you 7 hours to get across the pond and somebody else can do it in 3.5, it's a tough day, and you're going to have to find a way to get supersonic flight into your portfolio. Additionally, there's some great secondary applications for the aircraft. We're already working with the Air Force to adapt Overture for presidential and executive transport, because we think the US and ultimately the world should have an option for getting our leaders together in the same room in person as quickly as possible. All right, well, that is the introduction to Boom. As I said at the outset, our ultimate goal is high-speed flight for anybody. One of the reasons that we called the first airplane Overture is we see it as a start of a new era of high-speed flight, as well as a start of a journey for passengers. Well, thank you very much. I'm going to pause here and let Adam and Nils and all of you out there ask some questions.
Okay, great. Thank you so much, Blake. There are a couple of questions that have come in from the audience. And the first one is, here we go. How can airlines justify purchasing an aircraft that is remarkably less fuel efficient per passenger than subsonic models, as the word works to avert a climate disaster? Now, you mentioned that you could use sustainable aviation fuel, which is great, but on the other hand, that's like a bottleneck at the moment, and those fuels can also be used by very efficient subsonic aircraft like the 787 or the A350. So what can you say about the fuel consumption per passenger mile in comparison to subsonic flights?
Yes. So the way to think about this is flying, say across New York to London today on a 787 is sort of like driving a not very efficient SUV across the pond. And so you're emitting significant carbon. And flying Overture across the pond is going to be like driving an electric car. Because it runs on sustainable aviation fuel, there's zero net carbon emissions. Now, when you go faster, yes, you do burn more fuel per seat mile. That's a basic fact of physics. But because it's a different kind of fuel, the climate impacts aren't there. And if you think about the compatibility of different airplanes with sustainable fuel, a 787 or a modern Airbus aircraft, you can at most put 50% sustainable fuel on those airplanes today because they weren't designed to be compatible with latest generation, most carbon reducing sustainable fuel. So you can make some progress there, but not as much. Versus high-speed flight with Overture, you can have 100% reduction in life cycle carbon. Now, ultimately, we think Boeing and Airbus are going to catch up to this. Everyone's going to do it because this is the way that you decarbonize long-haul travel. But Supersonic is going to be there first and best.
Okay, but if I could just follow up on that, I mean, I guess you could design an engine and an aircraft that would be flying at subsonic speeds that use 100% sustainable aviation fuel, right? So comparing like for like, I mean, what would the additional fuel burn be per passenger kilometer?
Yeah, well, I don't want to get into the specific numbers. That's premature. It is more. But the way to think about this is it's ultimately about economics, not about climate. And when you go faster, that really is your main economic challenge, is how do you optimize the fuel burn per seat mile, because that drives a significant portion of your costs. On the other hand, and this is a thing that I think is often overlooked, is so many other costs on the airplane, be it maintenance, catering, crew, are proportional not to miles flown, but proportionate to hours utilization on the aircraft. So when you can turn an airplane, say, twice as many times as you can turn a wide body today, and you can get 65 passengers on and off the airplane a lot faster, you can complete block times a lot faster. You get utilization advantages. You get cost savings from those utilization advantages. And what you find is that on net, those cost savings offset the additional fuel cost. And it varies route to route, but the cost per seat mile can be pretty close to parity with subsonic business class today.
Niels, it's also a different product. It bothers me that people say compare the two products. It's kind of like saying I can go from here to Europe on a boat, or I can fly. Well, yeah, they're different products. Once people will start getting used to, and if it's only in the beginning, only those who pay a premium. But once you get used to flying 3 hours, you're not going to go back to 6, 7 hours. It just won't, and it's even more to Asia. Before COVID, used to fly often to Asia. I don't want to be 16, 18 hours on a plane. And will I be willing to pay more? Yes. Are there enough people that are willing to pay more? Yes. Are ticket prices going up regardless of supersonic or whatever we do? Definitely. So it's a different product. We have to accept the fact it's a product that modern people actually want. We don't have patience to wait. And by the way, Blake, you didn't mention about how many people fly. What is the seating?
Yeah, it's 65 seats in the configuration that I showed on the screen. So really generous, lots of legroom, lots of space at 65 seats. And if you go to a Concorde-like comfort level, you can get 88 plus passengers on the aircraft. But we think 65 is pretty close to where the sweet spot's going to be, because you want to build an experience that is a repeat travel experience for passengers.
Do you see it's changing? I'm sorry, Niels, I jumped in, but and we let Niels tell you about the concerns of our members. But can you see a period where you will want smaller planes also, more like regional or even bigger? How flexible are you eventually? I know you didn't make the first flight yet, but how capable will you be to change the seat size?
Yeah, so if you think about the longer range roadmap here for supersonic flight, I think it's instructive to go back again and look at what happened when we went from props to jets. And it was incredibly demand stimulative. When you speed up travel, you get both higher fares and more volume. And you can see like a tip of the iceberg on that today when you put a direct flight in place on a route where previously you only had connecting. You typically see an increase in demand and about a 12% increase in fares. So what happens with supersonic flight? Well, the first generation of supersonic and the demand models that I was sharing here are really just looking at taking existing passenger flows and speeding them up. Okay, but really there's going to be demand stimulation. There's going to be a lot more passengers. And what that means is that second and third generation supersonic aircraft are going to need to be larger to carry that passenger demand. And that kicks off part of a virtuous cycle. So you go to a larger gauge airplane, you can significantly improve the cost per seat mile. You're amortizing the pilots across more seats. Aerodynamically, a larger aircraft can actually be better than a smaller aircraft. So you get these additional sort of chasm benefits. And then those chasm benefits turn into ultimately the ability to offer lower fares, which means more demand. And that kicks off kind of a virtuous cycle where more speed ultimately leads to more demand, leads to reductions of cost in more speed, and therefore more demand. So I think we're going to see the airplanes get bigger over time, not smaller. Now, I do think there will also be a market for supersonic private aircraft. Now, that's very challenging today because the speed restrictions are still in place. And about 80% of miles flown on Gulfstreams, for example, are flown over land. And it's very hard to sell a product to a corporation or an ultra high worth individual when the airplane's not actually faster 80% of the time in real world usage. So I think we're going to see supersonic private aviation happen as well with smaller airplanes, but only after there's been regulatory certainty on acceptable sonic boom levels and you can design to it.
Okay, thank you. Blake, there is another question here, which I don't quite understand, but I think you will understand it, so I'm going to read it for you. Why buy J85 if not using afterburners? Why not use CJ610? Can these fly supersonic for 3 to 8 hours nonstop as of today, as presently built?
Yeah, so I think this question is really about the choice of engines on the XB1 prototype, not on Overture. On Overture, we're working with Rolls-Royce on turbofan engines, no afterburners, basically adapting latest generation wide body engine technology to have enough thrust to power supersonic flight. But on the XB1 demonstrator, it doesn't make sense to have a custom engine for a one-off prototype airplane. And so we picked the engines that were the right form factor and thrust level for that airplane. And in that case, you need J85s, and the variation of that engine that had enough thrust to do it with no afterburners was actually not importable. So we ended up with J85-15s that do have afterburners. CJ610s don't have enough thrust in that form factor. This is completely just an artifact of what engines are available that fit the airplane. And that's one of the principal differences between XB1 and Overture is it has to fly with off-the-shelf engines. You don't get to customize them.
And the final product will have what engine then?
We haven't announced the exact name and specs on the engine yet, but it will be a sort of medium bypass turbofan engine that is a derivative of current commercial cores. You basically take a wide body engine core, you scale the core up, and you scale the fan down, and that allows you to thread the needle. You want a lower bypass ratio for efficiency at high speed flight and a higher bypass ratio so you can be compliant with landing takeoff noise restrictions. That's one, again, big difference between Overture and Concorde is this airplane is certified to that your stage 5 or your chapter 14 noise levels, same noise levels on the ground as current generation subsonic aircraft, thanks to those turbofans.
Okay. And then there's a question that says, why only expect 100 private jets? I would have thought anyone with a $250 million yacht would want to have at least one. Maybe several thousand people could want to have this airplane.
Yeah, I think I touched on this earlier, and it's really the restriction on high-speed flight over land. Very few people have more than one private aircraft. And so you have to choose between say a G6 at the top end versus a supersonic aircraft. And if you look at, other supersonic business jets that were proposed, it was, a product that's 50% more expensive than a G6, 50% smaller than a G6, and then not faster 80% of the time in real world usage. And so customers in that scenario, they tend to prefer the larger, more comfortable aircraft because they're not getting speed ups most of the time. And so that's 100% an artifact of the speed restrictions over land. I think when you can get from say Tokyo to Seattle in 4.5 hours, and it actually takes longer than that to get from Seattle to Washington D.C., there's going to be a lot of motivation to straighten out those turn what is today a speed limit into what it should have been, which is a noise limit. And then Boom and others can go design aircraft that meet that noise limit. I think you'll see the Gulfstreams of the world enter the supersonic private aircraft market at that point. That's not something we're focused on. We're focused on commercial. And then you'll have high-speed flight everywhere, commercially and privately.
So Adam, are you going to get one for you when you go to China?
At least couple. With all my kids, I do need a couple of them. I have a question, Niels, if you allow me to jump in. You mentioned, Blake, that at least initially or right now, you are trying to get the front of the cabin, the guys who are willing to spend more money to fly with you. And how long will this go on? In other words, how long do you foresee that we will have people who want to spend more money and spend half the time flying, take these planes, and the peasants fly regular stuff? Now, peasants may still be differentiated, have their first class and whatever, but do you think that this will take a long time to eventually everybody accepting the fact that, no, it should be 3 hours to Europe and not 6 or 7 hours? How long do you see this happening? And I'm thinking, being old enough, remember when we had black and white TV, and there was a period where there were color TVs, and if you were richer, you could get color TV. After a very short time, it all became color TV. Yeah. So do you see a similar development, or because that for many of the ISTAT members, that's a critical question, because there's a stock of existing airplanes. And if suddenly how long is the transition period? Will the investments pay off over the years, or will it happen relatively quickly and suddenly they're stuck with obsolete stuff?
It's a great question. It's the timelines on this are relatively difficult to predict. But let's start with first principles. Like we were discussing before, when you speed up travel, you get demand stimulation. When you get demand stimulation, now you can justify a larger aircraft that's going to have lower fares. My suspicion is that getting to true parity with subsonic operating costs is going to require 2 or 3 generations of aircraft, and that they'll be spaced out in time, roughly like iterations of wide body aircraft are spaced out today. And each of those will require not just larger scale. They'll push the limits on propulsion. They'll bring new aerodynamic and systems advances along the way. So this will be, as much as from a passenger perspective, you'd love to change it all overnight. It's not going to happen like that. These are large, complex, take a long time to develop, and when you push to larger scale, you are pushing on supply chain and fabrication capabilities on some key components. For example, in Overture 1, basically the entire airplane is sized by the largest single crystal forged turbine blades that the industry knows how to manufacture today. So going to larger scale requires pushing things like that. So it'll happen, but it's not going to happen overnight.
Blake, there is a question here. How do you anticipate providing service for this aircraft? What do you think your customers expect from you with regard to maintenance? Will you approach service differently than a Boeing or Airbus? And before you answer that question, I think this could be seen in a wider context. I mean, to design an aircraft and kind of have the vision to see this new technology come, what about the certification process, the manufacturing process, and the aftermarket service? I mean, is this something that you eventually see yourself being sold to Airbus or Boeing, or is this something that is going to remain independent?
Yeah, I'll start with the last part and kind of work forwards with the question. When you think about our mission of making the planet more accessible and having not just this first airplane, but kind of a whole roadmap of airplanes ahead of us, to accomplish that, you do need to stay independent. I mean, ultimately, we'll do the right thing for our shareholders, but I see this as being like a Tesla compared to GM, or like a SpaceX compared to ULA. To achieve that vision, to achieve that roadmap, you need to stay independent. You need to stay nimble. So that's our aspiration for Boom. Okay, so how do you certify? How do you manufacture? How do you support the aircraft in a world-class way? From a certification perspective, first off, with Overture 1, you need to set yourself up for success by using only technologies that the certification authorities already understand, that they know how to prove, that there are known means to demonstrate compliance. And so you can think of Overture 1 as really 787 level technology, meaning a carbon composite airframe, fly-by-wire flight controls, lithium battery packs, et cetera. So things that have been proven safe, reliable, and efficient, where there are known means of demonstrating compliance for the airframe. And the things that make it different are really in the design, the thrust loading of the airplane, that kind of thing, rather than the basic technologies. And that sets you up not just for certification, but also to be skating downhill from industrialization perspective. So this airplane leverages capability in the supply base that already exists, that was built a decade ago for 787 and an A350. And we will control final assembly of the airplane, partnering with tier 1 suppliers that the same folks that build parts for Boeing and Airbus are going to build parts and subsystems for Overture. Around the end of the year, maybe late this year, early next year, we'll announce the factory location for Overture. We're down to a very small, short list of finalist sites and are in the process of finalizing that selection as we speak for groundbreaking next year. And that first final assembly line is going to be designed for rate 66 aircraft per year. So we'll be tooling that up here to deliver, deliver the volume of aircraft that the market needs. Now, as the questioner asked, you have to support these airplanes. And, first and foremost, the best support is the support you never need. Meaning the aircraft is very high dispatch reliability. It works day in and day out. It doesn't go on the ground as much. And it's when it does need maintenance, it's easy to get and inexpensive to get. So those are the first principles. And of course, if you have a Overture Go AOG, it is much more painful than subsonic because you don't want to divert your passengers to a subsonic flight. You want to divert, that is a much bigger step down versus a subsonic aircraft failing for another subsonic aircraft. So that fundamental dispatch reliability is important. And we anticipate most likely partnering to have a global support and maintenance network. This should be a best-in-class experience for airlines, both in terms of the fundamental reliability of the product, as well as when it needs maintenance or something doesn't go according to plan, the ability to get that back flying again should be world-class.
Thank you. There's a question from Will Conway. First of all, he's very appreciative that ISTAT hosted this, and he's thanking you and Adam for sharing your wisdom in this on this topic. And he's asking, where do you see the largest supply chain gaps appearing as supersonic aircraft scale over the next 10 to 25 years? Is it production of sustainable aviation fuel? Is it Overture construction materials, components for maintenance, etc.?
Yeah, I'll start with what it's not. It's not basic components and materials for the aircraft. Carbon fiber composites exist, great scale of supply chain there, both for production of the basic materials as well as components. In avionics and systems world, we're seeing some short-term issues with the global chip shortage, but that's going to get solved well before Overture enters service. So what hurdles do you face? I think in the first generation, the scalability of sustainable aviation fuel is one of the most important things. And so if you double click on that, there are really three generations of sustainable fuel technologies. The first and oldest is biofuels, built off of crops or in some cases off of waste oils. And those have some fundamental scalability problems because as a society, we don't eat enough French fries to produce enough waste oil to build enough jet fuel out of that, and nor should we. But they're second generation sustainable fuels, for example, that are based on municipal waste, that is based on trash, that are significantly more scalable. That said, we still don't have enough trash to build enough jet fuel. So it's really the third generation of sustainable fuels that are the most exciting from a scalability perspective. And those are what's called power to liquid today, meaning you use green energy sources to remove carbon from the atmosphere, liquefy it, and then convert it into sustainable fuel. And the great thing about these power to liquid fuels is that they're basically infinitely scalable. That the feedstock for these things is carbon that's removed from the atmosphere. And so if you run out of carbon in the atmosphere, you definitionally solve the problem. And because of the basic physics of it, it can also be 100% carbon neutral on a life cycle basis, which is very difficult to get to with earlier generation sustainable fuels. So scaling those today, those are working in small scale with good economics. If you look at the should cost inputs, how much power is needed for a gallon of jet fuel, the numbers are really exciting. And you can see a path there to getting to a cost parity or maybe even a cost advantage versus fossil jet A. And at the same time, the process is infinitely scalable because the feedstocks are unlimited.
Thank you. And on the topic of power, why 3 engines instead of 2? Is that because of ETOPS or what is behind that?
It has to do with how do you get enough thrust onto the airplane. The old adage was you had to have afterburners to go supersonic. You don't. You just have to have enough thrust to overcome the drag. And as I think I hinted earlier, the engine sizing limit today is based on what are the largest single crystal turbine blades that we know how to make. So that sizes the engine. and then you say, well, how many engines do I need to have enough thrust to carry enough passengers at a high enough speed? And it turns out you need more than a twin. That said, when you think forward to second and third generation aircraft, there's no basic reason why you want this to be a trijet.
Okay, and Will has another follow-on question. Would it ever be possible to have electric propulsion to go supersonic?
So battery electric, it would be very challenging, not just for supersonic, but really for any long haul flight. And the reason is that batteries are just significantly heavier than jet fuel. The best batteries you can get today weigh about 50 times more per unit of energy than jet fuels. And in fact, that's actually one side benefit of sustainable fuel. The energy density of sustainable fuel is actually better than the energy density of fossil jet A. So batteries are getting better, but they're getting better really slowly. There's about a doubling of battery energy density every decade. So it's kind of like a Moore's law, but very slow. So if you think about how long it takes to close a 50-to-1 gap, that's decades. And moreover, when you burn jet fuel, the airplane gets lighter, but when you discharge a battery, it really doesn't. So it's a very long runway for long haul battery electric aircraft. That said, could there be a hybrid electric propulsion system? That's a possibility. It wouldn't surprise me if we saw that somewhere along the way.
But if for some reason one day you could beam the electricity to the aircraft and not have to worry about batteries, is it technologically possible to reach supersonic speeds with electric propulsion?
Yes, if you have, absolutely. It's a matter. The problem with electric propulsion is, how do you get the energy to the aircraft?
Yeah,
and how do you get enough of it? It's not, can you use a electric fan to go high speed? You absolutely can. And in fact, there's some really significant advantages. Because if you look at what drives challenges in gas turbine engines at high speed flight, it's largely about temperature. And an electric fan-based propulsion system would not have those same thermal challenges. So if you had a supersonic hybrid electric powertrain, there could potentially be some real advantages. But so that's something that we think about for Overture 2, Overture 3 as possibilities. But with Overture 1, we're going for things that are ready to certify today, which is not hybrid electric.
Right. Okay. And then, of course, there's a lot of interest here on the United order. I mean, can you elaborate a little bit on that? What are they paying for the aircraft? What kind of performance guarantees are they requiring, et cetera, et cetera?
Well, as you'd expect, I can't talk about it in too much detail. One thing I can share is that the list price of the aircraft is $200 million a copy, and we've actually never discounted the airplane. And that's because it's a very unique capability aircraft, no near competitor. And as I was sharing the presentation, with the highest yielding passengers and better aircraft and asset utilization, you're able to get great profitability per airplane. And then United put their money where their mouth is on the order with a meaningful, industry standard non-refundable deposit.
And what else is in the pipeline in terms of orders from airlines?
Well, ultimately, this is something that I would expect every international airline to need. And so we're having a bunch of conversations with a bunch of different airlines. And I think we'll see more developing there over time.
Yeah.
I'm sorry, you mentioned competition, and it's not a pleasant subject, but when you become successful, others will try to jump in, and we humans want it to happen, and it will make your product better and your company better. And once it starts moving, progress will continue. Do you see any competitors around the corner coming? What prevents others from joining the race?
Yeah, well, fundamentally, I think competition is a great thing. And I'm actually surprised that we don't have more at this stage. Boom is the only independent company ever to have built and rolled out a supersonic jet. we're the only ones working on a current generation technology, current regulatory framework, high-speed flight. And ultimately it's not going to stay like that. There will be some tipping point when other new entrants and other established players decide they can't be out of this market, especially as you see cost of high-speed flight dropping, it becoming more mainstream and replacing more of today's market. So my crystal ball isn't clear enough to tell you when any of that is going to happen. History in other markets, if you look at, say, what happened with electric vehicles, for example, you had to get to a pretty big tipping point before you saw both a lot of new entrants and a lot of incumbents pursuing that market. So is that an analog for what will happen with supersonic flight? Maybe. I don't know. Time will tell.
Blake, I'm also an impatient guy, just like Adam, and I want speed. But if I'm flying from New York to London, right, what I'm really interested in is the time from when I leave my house until I arrive in my hotel room. And there I need at least an hour to go to the airport, and at least an hour to stand in the check-in line, to stand in the security line, to do the COVID checking. And then I need 7 hours to fly in the air, probably another 40 minutes of taxi at Kennedy. Okay, and then I need another hour to clear immigration, wait for my bag, and then an hour to get from the airport to my hotel. So that's between 11 and 12 hours. And if I fly with your plane, I mean, all these things around it is the same. And so I only actually get away with like 70 to 75% of the travel time door to door. Isn't there more low-hanging fruit that could be cheaper that has to do with how you get from your house to takeoff and from touchdown to your destination?
Yeah, I think it's a great question, and it resonates with me completely. When you've got you can fly across the pond at twice the speed, it's going to make all those other, I'll just call it very subsonic experiences, stick out like a sore thumb. And you might say, okay, is there a lot of low-hanging fruit there? You would think the answer might be yes, but if you look across the last, say, decade, those things haven't gotten better; they've actually gotten worse. And if you think about airports today and how efficient they are, the best airports from how long it takes to get through them are all small airports. All of our large airports, get more cumbersome. So, and I think there's actually an opportunity here for high-speed flight to motivate, kick off, and drive innovation in that end-to-end experience. So one of the things we're working on, with United and others is what does it look like to create a supersonic passenger experience, say at Newark. And when you can, again, when the flights are faster, what else can you do in that end-to-end experience to make it more tranquil, more comfortable, more convenient, and a lot less time? And so there's more to come on that front. But yes, those long security lines and other delays are going to stick out like sore thumbs for supersonic, and we're going to find ways to solve that end-to-end passenger experience. So I think and that is just as the analogy with small airports can be more streamlined, that's one of the advantages in building what is initially a 65 passenger aircraft. You can do things for 65 passengers at a time that are much harder to do for 300 passengers at a time. And so you can, quote unquote, do things that don't scale, that add to that value proposition, for those passengers.
Yeah, one of the problems, by the way, with the Concorde was the limited range. And the benefit is going from here to London, if I can save 3 hours, going to China can save me substantially more. This is when it really matters. Yeah. So to me, this is the way to go for at least start with the longer range. Yeah. And then Niels's math, changes a little.
But one good thing with their limited range of the Concorde was when you got into Paris or New York or London, because of the limited range, you had priority in air traffic control, and you never had to sit in a waiting pattern or holding pattern around, London or any of those cities. So that was what was like an advantage. if you could between those two cities. Look, Blake, I think that, Eduardo Morris has asked another question again about energy consumption. And I think this resonates with a lot of people, not only in this audience, but people generally at ISTAT. And that is that, the climate change and environmental impact is a concern. And it's a matter of limited energy resources. And if you have sustainable aviation fuel, that's great. But on the other hand, supersonic travel will still kind of take a bigger share of that available fuel than subsonic air travel would require. So I think this must be one of the public perception issues that you must be struggling with, I can imagine. Are you concerned about regulatory restrictions and public backlash?
Short answer, no. In the regulatory community, the public community, people are incredibly excited about this. And let me take a step back and be philosophical for a moment. Do we have a climate challenge? Yes. Do we need to figure out how to reduce emissions from aviation and from many other sources? Yes, absolutely. I think there's a pretty broad consensus on that at this point. But when you face that kind of conundrum, philosophically, you can go two different ways. You can say, well, we need to conserve, we need to use less, and we need to travel less, as an example. And I think that's really the wrong mindset. Because if you go back and you look at the incredible benefits of aviation, they are so significant. And think about a world. Imagine in a future generation of flight, you could get anywhere in the world in 4 hours, and you could do that at operating costs that make that accessible for basically anybody. Think about the way we would live our lives. Think about the experiences our children would have, having broken bread with every culture, not just kind of read about them in textbooks and YouTube videos. I think that's incredibly significant. And so when you face a sustainability challenge, my view is that instead of saying let's conserve, you say how do we create plenty, and how do we do that in a sustainable way? And that's why the capability to use SAF is important. And that's why very specifically the latest generation sustainable fuels that don't have scalability challenges are so critically important. That's why power to liquid really matters, because we have plenty of sunlight coming to this planet, and we certainly have plenty of carbon in the atmosphere. And those are really the two ingredients. Besides that, it's industrial technology that when you go look at the places that are building this stuff today, it exists, it works. We just need to build more of it. And there's no fundamental scaling factor there. And so if you believe, as I do, that SAF is going to become infinitely scalable and economic, then the question really becomes, okay, how do we build the best capability for humanity? And that's going to be faster flights.
Right.
And I think this is I'll throw one other thing on the end of it. From a public perception and regulatory perception perspective, 10 years ago, the assumption in the world was that if supersonic flight ever made a comeback, it'd be a private jet. And that is, I think that's something that should exist. It is a much harder thing to sell to the public and sell to the regulators versus let's build aircraft that, you and I can afford to fly on. And when you see an Overture flying up head, if it's not something that you're going to be on already, you look and say, well, I know there's a second generation coming or a third generation. I'm going to be on that one. And then you get excited for the future. So no net carbon emissions, no increase in airport noise, fares that are going to come down over time, so more and more people can benefit. That creates an environment where the public gets really excited.
Adam, any final words?
No, I do hope this is coming soon, and I actually firmly believe in it. Sorry, Blake, if I then said I'm not willing to invest money in it, because I'm an analyst. I'm not an investor, but you do need people like you who push new ideas, and you need some people who will invest in it, who are willing to take chances. So I do hope we have enough people who are willing to take chances, and I do believe it will happen. I firmly believe it will happen. This is the reality. And I hope to be on these flights, not just my kids and grandkids.
Absolutely, Adam. It's going to happen not just in your kid's lifetime, but in your lifetime. And I'm glad to have you, I'll call it morally on board today, and looking forward to having you literally on board in the not too distant future.
Just go easy on the chocolate, Adam. All right. Thank you so much, Blake and Adam, for that. Very interesting. And we see you back on November 23rd with Leah Ryan from Alton. Thank you, guys.
Thank you, Neil. Thank you, Adam.